All right, good evening, mathematicians. So in today's video, we're doing 1.1.3. This is all about writing equations from word problems and then using those equations to help us find some information that we are looking for. Okay, so in this curriculum, it talks about this thing called the 5D process. So the 5Ds are describe, define, do, decide, and then finally declare. Okay. I myself am not too familiar with this, but this is just to give you guys a foundation, right? Kind of a starting point of how do we write an equation from a word problem. Okay. The one thing that they say about the 5D process is that actually it will take a lot more time than if we were to just write an equation and solve it. So I want you to take a look here. So in this first example, see these two trials, right? So this means that the people who were writing this actually did kind of a guess and check type of process when solving this problem before they actually wrote an equation down here where I starred. Okay, so the 5D process is good, especially for when you're first starting out writing equations, because it kind of puts everything into perspective and you can see it nice and neat and clean. But again, it does take a little longer than just skipping over to my star here and solving the equation that way. Okay. So what I'm going to do in this video is I'm going to maybe do like the first 2 or 3 problems setting it up this way, and then I'm going to show you how I like to set it up, but it's more or less doing the same thing. So let's get started then. I'm not going to work through these examples. Instead, I'm just going to go straight to the problems, okay? All right. So a wood board is 100 centimeters long, and it's cut into 2 pieces. Okay, so that's the first thing. So the first D was to describe. Also, I saw earlier that you could either describe or draw. So I like to draw. So, I mean, I'm not that great at it, but, it's fun. Okay, so here's my wood board, and I know that the entire length is 100 centimeters. And let's see, I know that one piece it's going to be cut into 2 pieces, and one piece is definitely longer than the other. So I'm going to say that my cut is somewhere like there. Okay. What are the lengths of the 2 pieces? So, okay, I have my describe/draw. So here, my next thing, and this is typically the first thing that I do, is I like to define the things that I am working with. Okay. And this is important so that way, your teacher, when they're grading, they know exactly what you're talking about, right? We define things, especially unknown things, which is what we're working with here, okay? So I have 2 pieces, right? So I'm gonna say my short piece. I have a short piece, okay, and then I'm gonna have a little divider there. Then I have my long piece. Okay, and I'm going to say that my short piece is x. Okay, so we don't know how long the short piece is yet, but they do give us some information about the longer piece, right? One piece is 26 centimeters longer than the other. So I think it's safe to say that the length of the long piece in terms of the variable x, right, would be the short piece plus 26. Okay. Let's see, what is some other information that we know? We know that the total length of the wooden board is 100 centimeters long. So, if I were to go back up here, let's see. Where do I... Okay, so the next D in the 5D process after define is to do. Right, we're adding these 2 pieces together. So I'm going to say this is my sum, and I know that it should equal 100. And then, hold on, sorry. I got a little bit ahead of myself. I'm writing the sum underneath the do, and then the last one is the decide. Okay, so the 100 should actually go right here. Okay, now what I'm going to write below sum is, well, I'm going to add these two things that I'm circling together, because that's what a sum is. We need to add those two things. So I'm going to do x plus 26, right? And then we're going to see if that is equal to 100. And actually, let me highlight this. This right here becomes the equation that I'm going to solve. So let's go ahead and write it out over here. X plus 26 is equal to 100. Okay, now we're just going to combine like terms. I have an x and an x. I add them together. I get 2x. Can't add the 26, so I'm going to keep it separate. And hey, look, I have a two-step equation that I now can solve. Right, so bringing back a little bit of solving equations review. By a little bit, I mean a lot. So I'm going to subtract 126 from both sides. Do a little bit of math here. It looks like I'm left with 74. And these 26s are going to cancel out. And so now I have 2x. 2x is equal to 74. Well, I got to isolate the x, so I'm going to divide both sides of my equation by 2. And a little bit of mental math here. That should be 27. That took me a little longer than I thought. Okay, so are we finished? That's the question we should be asking ourselves. Well, let's go back to the question and figure out what they want us to discover. What are the lengths of the two pieces? So if you were to just leave your answer like this, you probably wouldn't get, you'd probably get some points, but you probably wouldn't get many points because you did not answer what the question was asking you. So we need to determine the lengths of the two pieces. So remember, if you go back to the define section here, right? What did we define the short piece as? Oh, well, the short piece is x. So that must mean that the short piece is 27 centimeters, right? And the longer piece we know is the short piece plus an extra 26. So I'm going to go ahead and add 26 to my 27. So it looks like the two pieces are 27 centimeters and 53 centimeters respectively. Let's double check our work here. Take a look at the answers. 37 and 63. Uh-oh. What happened? I know what happened, guys. When I divided by 2, that should have been a 3, not a 2. There we go. That's much better. 37, and then when we add 26 to that, we get 63. Ooh, there we go. Okay, simple fixes, simple fixes. All right, let's keep going. Number 2. Let me go ahead and copy this. Okay, so 2 is 5 years older than her brother Tuan. Let me expand this a little bit. There we go. The sum of their ages is 51, and what are their ages? Okay, so let's see. I'm going to go straight to my define step here. Okay, so I have 2 siblings. I have Tu and Tuan. I'm going to say Tuan is going to be defined by our variable x, right? Because how they describe Tu's age is actually in respect to Tuan. So I'm just going to say Tuan is the x by itself, and then 2, well, 5 years older. I know I'm going to add 5 to Tuan's age. Okay, so after define comes the do section. So what are we going to do with these two things? Well, it says the sum of their ages is 51. So it looks like we're looking for the sum. The last thing is we're going to decide, well, what is the sum of these going to be? Well, that's going to be 51. Okay, so let's go ahead and write underneath the sum. Let's add my two expressions there, x plus 5, and it should equal 51. So again, I'm going to highlight this. This is my equation that I'm solving. So let's go ahead and write it below. So x plus 5 is equal to 51. Combine like terms, these two x's I can combine. Can't combine the 5 with the two x's, so I'm keeping them separate. And there we go, 2x plus 5 equals 51. Let's go ahead and solve this. Subtract 5 from both sides. And let's see, I get a 6 and a 4, so 46 is equal to 2x. There we go. And to get x by itself, I'm going to again divide by 2, just like I did in my last problem. And it looks like my x is going to be equal to 23. So I need us to ask ourselves, are we finished with the problem here? What is the question asking us? What are their ages? So x equals 23. Whose age is this? Well, 23 we said, or x is Tuan's age. So Tuan is 23. And then we also need to find out 2's age. 2 is, well, 23 plus 5 is 28. And there we go. How did we do? 28 and 23. Excellent. All right, let's keep going. Got to add another page here. Come on, you can do it. It's going to work eventually. In the meantime, I will copy and paste this. Let's see, did it add? Okay, yeah, it did. That's weird. Okay, so Tomas is thinking of a number. Immediately, that's kind of like a red flag is going off. Thinking of a number, it's an unknown value. We don't know what it is. So actually, it might be safe to define this number as x, right? So I will say let x equal Tomas's number. We don't know what it is. Okay, well, let's go ahead and see what's happening to this number. What are we doing to this number, right? And guys, I'm starting to drift away from that whole chart looking thing, okay? I'm just showing you how I would go about solving this and how it's essentially doing the same thing or accomplishing the same task. Okay, so it says if he triples his number and subtracts 13, the result is 35. Ooh, there's a lot to unpack here. So if he triples his number, so I know I'm going to be multiplying x by 3, right, tripling. Then I need to subtract 13. The result is typically represents the equal sign. So we're going to write an equal sign, is 305. This is the equation that we are going to solve. Okay, so this is kind of the do and the decide section. Okay. All right, let's solve this equation here. So isolating the variable, I'm going to add 13 to both sides of my equation first. Those cancel out, and it looks like I have 318 on the right side, and then I can just bring down 3x. Let's go ahead and divide both sides by 3, continue isolating the x. Let's see, a little bit of long division here. That goes in once. It's 3, 0, 0, 0, and there we go, 106. Of what number is Tomas thinking? They could have asked what number is Tomas thinking of. It looks like just plain old 106. So this would be our declare section. Okay, and there we go. Another problem solved. Let's do the next one. Question number 4. Ooh, this one's cool. 2 consecutive numbers. So in order to solve this, we need to ask ourselves, well, what in the world are consecutive numbers? If you don't remember, that's okay, I'm here. Consecutive numbers are numbers that happen right after another. For example, 1 and 2 are consecutive numbers, or 2 and 3 are consecutive numbers. So I'm going to say, so in my define section, I'm going to say that x, or let x equal the first number. Okay, And then consecutive numbers, like I said, in all of these examples, 1 and 2, 2 and 3, 3 and 4. Consecutive numbers are, the following number is always one more than the previous number, right? So the consecutive number is going to be equal to x plus 1. Okay, so that's how I'm going to represent my two consecutive numbers. I have x and then x plus 1. Okay, so this is again my define section. Okay, so what am I doing to these expressions? Well, that tells me what to do right there. They have a sum. So it looks like I'm going to be adding these two expressions together. So I'm going to be adding x plus 1, and that should equal 123. And then this is my decide here. And there we go. Let's go ahead and combine like terms. I have two x's, so I should write 2x plus 1 is equal to 123. Subtract 1 from both sides. These ones cancel out, so I bring down my 2x. 123 minus 1 is 122. Then I'm going to divide both sides of my equation by 2, and x is equal to 61. Okay, so again, am I finished with this problem? No, I'm not, because they're asking me what are the two numbers. So again, going back to our consecutive number, or our definition of consecutive numbers, if our first number is 61, then our second number has to be the next number in our counting order, which is 62. How did we do? There we go. Check. Awesome. Let's keep going, guys. Why isn't this working? Let's add another page and hope that works. Okay, well, we're just going to work like this. It's going to be out of order, but that's okay. All right, question number 5. So again, we're dealing with another two consecutive numbers. Okay, so two consecutive, even numbers. That's a key word here, even numbers. Okay, so have a sum of 246. What are the numbers? So what's nice is I can start this problem just like I started the other one, where I let x equal the first number. Okay, I'm going to list some examples. So my first number would be 2. The next consecutive even number would be 4. Okay, if my first number was 4, the next consecutive even number would be 6. Right? And then let's do one more. If my first number was 6, then the next consecutive even number would be 8. So we need to ask ourselves, well, what pattern is happening here? How much am I increasing by when I go from 2 to 4, or 4 to 6, or 6 to 8? Well, you might have noticed I'm adding 2 every time. I'm adding 2 to the first number every time. So the consecutive even number, is going to be, well, I'm just going to take my first one, which is x, and I'm just going to add 2. And that should be my two consecutive even numbers. Okay, there we go. Next is do. What are we doing to these? Well, again, it says a sum, so it looks like I'm going to be adding these. So I'm going to add my first number plus my second number, and that should equal 246. All right, let's go ahead and solve it. 2x plus 2 is equal to 246. I'm going to subtract 2 from both sides. These are going to cancel out. Drop down my 2x. 246 minus 2 is 244. My next step, I must divide both sides by 2, and x is equal to 122. Okay, so what are the numbers? Right, that's the question that they're asking me. What are the two numbers? So my first number is 122. My second number must be the next consecutive even number, which is 124. Let's double check. There we go. Not bad. Okay, let's keep going. I know there are a lot of problems here, guys, but these are all wonderful practice. Ooh, I like this one. This one's going to be fun. Okay. Number 6. Talking about ages here. There we go. Okay. Joe's age is 3 times Aaron's age, and Aaron is 6 years older than Christina. If the sum of their ages is 149, what is Christina's age, Joe's age, and Aaron's age? Okay. With this, when we're defining, right, typically what I do is I like to give the person who is the youngest, or I like to assign X to the person who is the youngest. So, we know that Joe is older than Aaron, and Aaron is older than Christina. So I'm going to say let X equal Christina's age. Okay, because, and the reason why I'm doing this is because I can actually write Aaron's age and Joe's age in terms of Christina's age, right? I can find their ages if I know Christina's age. So it looks like I'm looking for Christina's age. All right, so let's go ahead and talk about Aaron's age, or Aaron's age. Well, we know this is equal to, well, Aaron is 6 years older than Christina, so it looks like we're just going to add 6 to Christina's age, or X, okay? And then we know that Joe's age is 3 times Aaron's age, so Joe's age, that looks like Doe's age. Here, let me fix that. Oh, that's too much. Okay, let's just redo that whole thing. Joe's age, right? So we know that it's Aaron's age times 3. So I'm just going to rewrite that as, I'm going to take Aaron's age and plug it in. Actually, I'm going to rewrite it like, or actually I'm going to write it like this. 3 times Aaron's age. And there we go. So, well, what am I doing to these expressions? Well, it says, oh, hey, look, there's the word sum again. So we're just going to add them. We're going to add them together. So I'm going to add Christina's age plus Aaron's age plus Joe's age. There we go. I have my 3 terms there. And then we know that their sum is equal to 149. And now we have a little bit more of a complex equation, and that's okay. You know, we're just going to take it step by step. So first thing that I notice is, hey, look, there's a 3 outside of these parentheses, so I'm going to distribute. So this becomes 3x plus 18. Okay, I'm going to bring down everything else as well. And there we go. So I notice that I have 1, 2, 3, see the 3 little dots there? I have 3 terms with x's in them, so I'm going to combine them because I'm adding all of them. So x plus x is 2x plus another 3x is going to give me 5x in total. And then I can add my 6 and 18, which is 24. There we go. And now I have a 2-step equation I can solve. So let's go ahead and subtract 24 from both sides. And these 24s are going to cancel out, so I'm just going to bring down my 5x. And here I am left with 4 minus 2 is 2, 9 minus 4 is 5. And so I'm left with 125. I'm going to divide both sides by 5. So I'm left with x is equal to 25. So let me ask myself, am I finished here? No, I'm not. I need to find out Christina's age, Joe's age, and Aaron's age. So we said x is Christina's age, so it looks like Christina is 25. We need to find out, it says Joe's age next, but let's find out Aaron's age. Aaron's age is, he's 6 years older than Christina, so we're just going to add 6 and 25, so Aaron is 31. And lastly, Joe is 3 times Aaron's age, so 3 times 31, do that really quick, 93. Ooh, Joe is still kicking at 93, awesome. There we go, we have the 3 ages. Awesome, guys, we're halfway there. Hang in there. Let's add another blank page here. Oh, now it's working. It's showing up. Okay. And I think we are on excellent. Yes. Okay. Farmer Fran. Okay. So question number 7. Farmer Fran has 38 barnyard animals consisting of only chickens and goats. If these animals have 116 legs, how many of each type of animal are there? Okay, so there's a lot to unpack here just because we're talking about the amount of legs, and then also we're trying to figure out how many total chickens there are and how many total goats there are. Okay, so I'm going to say in my define stage, I'm going to let x equal the number of chickens. And you can do the number of goats, it doesn't matter. You'll still get the same answer, except the only thing that'll be different is what you're solving for. Okay, so when I solve for x, it's going to tell me the number of chickens. Okay, all right. So now I need to know, well, how many goats? How many goats are there? Right, well, if x is the number of chickens, and I have 38 total animals, well, if I do 38 minus the number of chickens, that should give me the number of goats. Okay? All right, the next part. We need to talk about some legs here. So, how many legs do chickens have? Hopefully you said 2, you know. So we know that chickens have 2 legs. So I'm going to write that over here. 2 legs for chickens. And how many legs do goats have? Well, they have 4 legs. So this is going to come into play when we write our equation. Okay, so I'm going to do, when I write my equation, I'm going to do 2x, right? So hang in there. I'm going to explain what these are in a second. 2x plus 4 times 38 minus x is equal to 116. Okay, so let's unpack this a little bit. I want to write out what each part means. So the 2 represents the chicken legs, right? There's only 2 chicken legs. The x in this equation represents the number of chickens. This 4 comes from the goat legs, right? Because goats have 4 legs, most of them anyway. Okay. This entire thing right here in parentheses, right? So here, let me draw a brace right there. That 38 minus x, that's my number of goats. Whoa, that's my number of goats. And then lastly, this 116 is the total number of legs. Woo, there we go. Okay, so this is the equation that we are going to solve. So let me go ahead and copy this. Copy, paste, there we go. Let's go ahead and solve it. So again, I see a number floating outside of parentheses, so I'm going to use my distributive property. I'm going to bring everything down first. So 2x plus, well, 4 times 38. Let's see, that's 32, 12, 15, 152, plus 152, minus 4 times x is 4x, and that is equal to 116. Let's go ahead and combine like terms. What is 2x minus 4x? Hopefully you said negative 2x plus 152, and that should be equal to 116. I'm going to leave my x on the left side of the equal sign. So now I'm just going to subtract 152 from both sides. And let's see, I made this harder for myself without a calculator here. Do some quick math here. 36, so that should be, so 116 minus 152 should be negative 36. And then these 152s cancel each other out, and negative 2x I can bring down. Okay, now I need to divide both sides by negative 2. Make sure you divide by negative 2, okay? X doesn't like to be negative, so we're going to get rid of that negative sign by dividing by a negative number. And we are left with x is equal to 18. So it looks like we have 18 chickens. And then how many goats do we have? Well, remember that there are 38 barnyard animals. So we're just gonna plug in 18 for x into our equation here. 38 minus 18, and that is 20. So it looks like we have 20 goats, or not we, but Farmer Fran. Farmer Fran has 20 goats and 18 chickens. Let's double check our work here. Yes, excellent. Okay. Let's keep going. That one was a doozy, wasn't it? It kind of stumped me for a little bit, and then when I really sat down and did it, I was able to figure it out. Okay. Number 8. A wood board 156 centimeters long is cut into 3 parts. The 2 longer parts are the same length and are 15 centimeters longer than the shortest part. How long are the 3 parts? Okay. Let's go ahead and paste this here. Okay. So if you like to draw, now would be a good time to draw, right? So we have a wooden board, and it's going to be cut into 3 parts. There are 2 parts that are equal in size. Hold on. Those are all equal in size. Okay. So there are 2 parts that are equal in size that are longer than the 3rd part, right? So I have 1 long, 2 long, 1 short. Okay. The 2 longer parts are the same length and are 15 centimeters longer than the shortest part. So I'm going to let x equal the short part, because I can write the length of the long part in terms of x, right? They say that the long parts are 15 centimeters longer, so we're going to say x plus 15. Okay, so there's my define, right? Still doing this, still doing the 5D process, kind of like under wraps now. Next, what are we doing? Well, we know that the entire length of the board is 156 centimeters, so we are going to add them together. X plus 15. Don't forget the second x plus 15, right? We have 2 long sections, so we need to include both of them. And we know this is equal to 156 centimeters, and this is my decide. Let's go ahead and combine like terms. I see 3 x's, so I'm going to combine them into 3x, and I see 2 15s, and that's going to be 30, and I'm adding everything together, so therefore the plus sign is still there. So here's my equation. 3x plus 30 is equal to 156. Let's go ahead and solve. I'm going to subtract 30 from both sides. There we go. This becomes 1, 2, 6. These 30s cancel out, and I bring down my 3x. I'm going to divide both sides by 3. So I'm left with x is equal to 42. And there we go. Okay, but they're asking us how long are the 3 parts. So the shortest part is 42 centimeters. And then the other 2 parts are 15 centimeters longer. So what is 42 plus 15? That's going to be 57. So the lengths of the 3 parts are as follows: 42, 57, and 57. Double check our work. Hey, there we go. Awesome. Hang in there, guys. We're almost done. Almost there. Okay. Number 9. Let's copy that. Bring it up here. This one's kind of similar to the Farmer Fran one. Okay. So I'm going to, in my define section, I'm going to say let x equal the number of nickels. Okay. Sorry, I forgot to read the problem. I'm getting ahead of myself. Juan has 15 coins, all nickels and dimes. This collection of coins is worth 90 cents. How many nickels and dimes are there? Okay, and so in their hint, they say create separate column titles for number of nickels, value of nickels, number of dimes, and value of dimes. And that's all going to be taken care of behind the scenes, okay? So let x equal the number of nickels. Well, how am I going to write the number of dimes in terms of x? Well, remember that I have 15 coins in total. So if I were to subtract 15 and the number of nickels, I should have the number of dimes, okay? And let's really quickly review. What's the value of a nickel? How do you write that in numbers? Well, remember that a nickel is worth 5 cents, and we write that 0.05, okay? And then dimes, remember that dimes are worth 10 cents, or 0.10. Okay, so these are gonna be integral into our in our equations. Okay, so what am I doing to these things? Well, I know that I'm going to be adding the number of nickels to the number of dimes, right? So I'm going to do this. I'm going to write 0.05 times x plus 0.10 times 15 minus x. And when I add these two things together, they're going to come out to 90 cents. Right? So I lost my train of thought. Okay, well anyway, so here we have, let's quickly go over what each of these parts means. And again, this is important so that way you guys don't forget what every part of your equation means. So 0.05 represents the value of a nickel. So I'm going to write value nickel. X is the number of nickels. 0.10 is the value of a dime. This thing in parentheses, 15 minus x, that is the number of dimes. And this right here, 0.90, is the total value of all of Juan's nickels and dimes. Okay, so let's go ahead and solve this. Oh, there we go. Okay, so I see a number floating outside of parentheses, so that makes me want to distribute. So let's go ahead and do that. I'm going to bring down 0.05x. I know that 15 times 0.10 is going to leave me with 1.50. And then 0.10 times x is going to leave me with minus 0.10x. Okay, and then I bring down my 0.90. Okay, let's combine like terms. 0.05x minus 0.10x is going to be negative 0. Negative 0.05x. Sorry, I was debating whether or not to do 0.05, and I was like, yeah, that's too many zeros. So negative 0.05x plus 1.5 is going to be equal to 0.90. And now let's go ahead and solve this. Let's subtract 1.50 from both sides. Make sure that you line up your decimals, please. 1.50, and I'm subtracting. There we go. So we can do this over here on the side. So we are left with negative 0.60, and that is going to be equal to negative 0.05x. And might help if you have a calculator. So let's go ahead and do, we're going to divide both sides by negative 0.05. Please don't forget the negative sign. That's going to affect a lot of things. So we are going to do negative 0.60 divided by negative 0.05. Make sure it's a 0.5 in there, please. So x is equal to 12. So it looks like we have 12 nickels. And we said that 15 minus 12, or 15 minus x, should give me the number of dimes. So it looks like there are 3 dimes. Cool, another one done. Oh, I took the entire page. I didn't mean to do that. Okay, let's add another page. All right, number 10. We're selling tickets to a school play. That's what we're selling tickets for. Okay, so let's read this first. So tickets to the school play are $5 for adults and $3.50 for students. If the total value of all the tickets sold was $2,517.50 and 100 more students bought tickets than adults, how many adults and students bought tickets? Okay, so I'm going to say in my define section, I'm going to let x equal the number of adult tickets or adults. And the reason why I'm doing this is because I know for sure that there are fewer adult tickets than there are students, right? And this right here, what I'm going to underline, tells me that 100 more students bought tickets than adults. So I'm going to let x equal the number of adults. Okay, so that means that the students, the number of students should equal 100 more than the adults. So I'm going to do x plus 100. Okay, but they're not asking us, they are asking us how many adults and how many students. We're going to take into account the cost for students and the cost for adults to help us solve this. So we know that the adults cost $5 each and the students cost $3.50 each. So I'm going to include those in my equation here. So I'm going to do 5x plus 3.50 times x plus 100, and I know that equals a total value of $2,517.50. And there we go. Okay, you might need your calculators on this one. Let's go ahead and get started. So I notice a 3.50 floating outside of parentheses, so I'm going to distribute 3.50 to all of the terms inside. So that becomes 5x plus 3.5. Actually, guys, I'm going to get rid of the 0. So I'm just going to write 3.5x, okay? Because I don't need it. Then 3.5 times 100 becomes 350. And that is equal to 2517.50. Let's combine like terms. 5x plus 3.5x is 8.5x plus 350 is equal to 2,517.50. There we go. Okay, let's solve this. Minus 350, remember, line up your decimals, please. Minus 350. So it looks like we are left with 50 cents, and then that becomes a 7. I'm going to borrow from there. 2,167.50. And these 350s are going to cancel each other out, so I just bring down my 8.5x. So let's see. Fingers crossed that 2,167.50 is divisible by 8.5. Hey, look at that. It is. Whoops. Sorry, I got ahead of myself. I should have written, and yes, you must do this. You must show all of your work and how you got to your answer. Boom, there we go. X is equal to 255. What does X represent? That's right, the number of adults. So that must mean that 355, right, 255 plus 100 is equal to the number of students. Let's double check our work. Number 10, number 10, number 10. Excellent, yes. All right, two more to go. Number 11, we're back to wooden boards. Copy. Pasta. Okay. Oh, that's too much. There we go. A wood board, 250 centimeters long, is cut into 5 pieces. 3 short ones of equal length So 3 short ones that are equal in size, and then 2 that are both 15 centimeters longer than the shorter ones. What are the lengths of the boards? So I'm going to say let x equal the shorter board, or the short board, okay? And then for the long boards, right, we know that they are 15 centimeters longer, so we're just going to do x plus 15. What am I doing to these expressions here? Well, I'm adding them all together. So remember, there are 5 pieces total. We have 3 short pieces, so I should have 1, 2, 3. Then I have 2 long pieces, so I should have 2 of the x plus 15s. Please get my order correct, please. And we know that the entire length is 250 centimeters. So now we have a crazy long equation. Well, let's count how many x's I have. I have 1, 2, 3, 4, 5. So that must mean when I add them together, they equal 5x. Then I have 2 15s. I know 15 plus 15 is 30. There we go. Look, I got a 2-step equation to solve. Let's go ahead and solve it. So we're going to subtract 30 from both sides. These 30s cancel out. So I'm left with 5x on the left side. 250 minus 30 is 220. And I'm going to divide both sides by 5. 4. Is that 44? I believe so. Yep, that is correct. Okay, so the short boards are all 44 centimeters long. So we have a 44. We have another 44, then we have another 44. Then we know that the longer boards are 15 centimeters longer. So 15 plus 44 is going to be 59. And I'm just going to put centimeters at the end. There we go. Excellent. All right, we're on the last one, guys. Kudos to those of you who made it to this far in the video. So, all right, here we are. The final problem, number 12. Okay, so we're back to dealing with some coins. So Conrad, that's a cool name. Conrad has a collection of 3 types of coins: nickels, dimes, and quarters. There's an equal amount of nickels and quarters, but 3 times as many dimes. If the entire collection is worth $9.60, how many nickels, dimes, and quarters are there? Okay, so I know there are 3 parts here. There are 3 different things that we're working with, but remember, nickels and quarters, they have the same amount. So when I define my variable, I'm going to say that let x equal the number of nickels and quarters, right? They have the same amount. Then I know that the number of dimes is equal to 3 times as many, right? So 3 times x. Okay, but here's where things get a little tricky. Remember that nickels have a value of 0.05 and quarters have a value of 0.25. And then dimes, of course, have a value of 0.10. So I'm going to include these values in my equation. So I'm going to take 0.05 and multiply it by the number of nickels plus 0.25 times the number of quarters, right? It's the same variable. Then I'm going to take 0.10, or the value of a dime, multiply that by how many dimes there are. And I should come out to $9.60. So let's go ahead and do this really quick. 0.05x plus 0.25x plus, we should multiply first, 0.10 times 3x. So that should be, really quickly here, is 0.3x, there we go, and that is equal to 9.60. Let's go ahead and combine these, right? All of these terms have x's attached to them, so we can definitely add these. So we're going to add 0.05 plus 0.25 plus 0.3. So that comes out to 0.6x is equal to 9.6. And then we're going to divide both sides by 0.6. And let's see what happens. X is equal to 16. So remember, we have 16 nickels, 16 quarters, and then we have 3 times as many dimes, so 3 times 16 is 48. So let's double check our work here. 16 quarters, 16 nickels, and 48 dimes. There we go. All right, you guys, congrats if you've made it to the end of this video. I'm so proud of you. Keep up the hard work, and I will see